Alright, I'm back with to solve some examples. So the examples after we establish the process is actually fairly straightforward because these are just numbers in front of these. I gave two examples, so I'm going to start with those and I'll solve more. So you can see that these are simply numbers. So depending on b squared minus 4ac value, I will go at a different type of solutions, but then the solution is easy after we cover the approach that we need to establish, right? So let's go ahead and solve this one. I write two of them because it's kind of short, you'll see. This 4m squared. By the way, this is called the ancillary equation. Okay, this type of stuff that we're writing here is called the ancillary equation. I forgot to say it in the last segment. Okay, and then basically what I'm going to do is I will look at minus b plus minus, you know this, b squared minus 4ac by 2a, right? By 2a. So let's write it in here. m1 comma 2 will be minus 1. You know, this is a, this is b, b is 1, c is 0, plus minus square root of 1 square minus 4 times 0, right? That is the c, divided by 2a, which is 2 times 4, right? So let's put it in parentheses so it doesn't look like a 4.4. So you can see in here I will get myself minus 1 plus minus, what is the square root of 1 square? So that's 1 divided by 8. So I will get 2 roots. One root will be 0 if I use a plus sign. If I use a negative sign, I get myself minus 1 by 4, right? So the point is, these are both real roots. So if I go ahead and write this, the way that we established this, it's going to be c1 e to the 0x plus c2 e to the minus 1/4 x. Just like this. Okay? So what is this? This is 1. So I get myself y is equal to c1 plus c2 e to the minus 1/4, or let's call it that, x by 4, right? That's better. So that will do it for this particular question. Okay, let's go ahead and analyze this particular question. So the ancillary form will be m squared minus 10m plus 25 is equal to 0. And I'll do the same trick that I did here. So basically I had to calculate this. I don't want to rewrite this. So it's going to be minus 10, it will be 10, plus minus square root of minus 10 squared, b squared, minus 4, a is 1, c is 25, divided by 2a, right? So that is 2. So you can see here that this whole thing will be 0, right? 100 minus 4 times 25, so that's gone. So then I get myself m1 comma 2 will be 5. So I'll get a double root at 5, okay? So by the way, let's go ahead and write this. This is case number 2, right, that we covered. And this is case number 1 that we covered, right? Just to be on the same page. So then, if we follow the rules that we established for case number 2, then you will write this way. Y will be equal to c1 e to the 5x plus c2 x e to the 5x. So that will be the, basically the, let's also underline this, that will be the solution for this particular case. So I have two more questions to illustrate the concept, and they will be from case 3, you can imagine. But let me just give a break over here, so I don't want you to watch me, writing a question. So I'll be right back with a good page for you to start with, okay? All right, I'm back. But one interesting thing is this is the question I solved in the last segment, if you remember. Reduction of order. So I said that one of the roots is sine 3x, and I said that go ahead and find the other one, and we demonstrate that it's going to be cosine of 3x. So why don't we solve it? Because I didn't really solve it. In that case, I had to have one particular solution given to me. So now I'm going to demonstrate how to approach this particular problem. So if I write the ancillary form, I'm going to get myself plus 9. One thing I want to highlight is, yeah, these are easy and all, but don't, I'm doing it, you're not doing it. So, m squared, you may say 9m, right? You see? It's not 9m, it's 9, right? Because this is supposed to be, y prime. So the y prime is missing here, right? As y prime is missing, this is how you write it. Careful about these things, okay? So I get myself m squared is equal to minus 9. So I get myself m1, 2 will be equal to plus minus 3i. So right there and then I got myself a case number 3, right? Case number 3. I got myself a complex roots, right? Okay. Again, I'm not going to panic. But one thing is, this is 0 plus, right? So this was alpha. this was beta, and when I write this formula. So if you remember the formula for it, y e to the alpha x 0x, and then c1 cosine of 3x plus c2 of sine 3x. Okay, as this is 1, so I got myself y is equal to c1 cosine 3x plus c2 sine 3x. Did you remember? This was the exact same thing that I find. This is the general solution. This root was given. I find this cosine of 3x by using reduction of order, and I multiply by c1 and c2 to constants so that I can get myself a general solution. So I get the same thing, you see? Now I don't need to know one of the solutions. So let me do one last question, because I have done case 1, case 2, case 3, so but just for a good measure. Ancillary equation is going to look like this. And 1, 2 is going to look like this. 4 plus minus square root of 16, 4 square, minus 4 times 1, a is 1, times 5, c is 5, divided by 2a, which is 2. So from here I will get 16 minus 20, so that's minus 4, right? Minus 4. If you take the square root of it, you're going to get 4 plus minus 2i by 2, right? So you're going to get 2 plus minus I. Okay? So if you write it this way, then this is alpha, this is beta. So this is case number 3. Okay. Let's go ahead and write the final answer. It will be e to the power of 2x, because it is alpha, c1 cosine x plus c2 sine of x. Well, I don't know what else to solve. I can keep going, but I think I made my point fairly clearly. So what I will do next is I will look at the higher order. I only established this for second order differential equations, but the title of this whole module is how sets of modules of higher order. It's not just second order. So I'll be back with third and higher orders. Okay? Thank you for watching this segment. Take care.